Using one example, I'm gonna explain all the objectives of this chapter and how to use StatCrunch in those objectives. First of all, let me remind you how to construct a frequency distribution table. Let's say we want to construct a frequency distribution table with 5 classes. So there are 5 rows of data. First of all, when you have a column like this, you should sort it out, because in order to construct the table, we need the class width, and the class width requires that we know the lowest value and the largest value. So this is how you sort the data. Sort, select the column, and right here, compute. And here you go. So now we know the lowest value is 134 and the largest is 250. So in order to find the class width, you take 250 and subtract it from 134, and that will give me what? 116. And then you take 116 and divide it by 5. There will be 23.2. And for the class width, guys, we need to round it up to the next whole number. So the class width is 24. That's all I need. I need the lowest value. Oh, I think I made a mistake here. Should have been 111, the lowest value. So let me just put 111. So that should give me 139. And then we take 139 and divide it by 5, which is 27.8. Okay, we need to round this up. And so the class width is going to be 28 to the next whole number. That's all I need to create the table. Let me show you how to create the table. So you go to stat tables, frequency, which variable we're doing, variable 1. And we need a frequency, let's say, and a relative frequency. Hold down the control key and press it right there. If you want a cumulative frequency, it will do it for you. Let me just add it. And now here, make sure you see the whole thing. Okay, we need to go to the bandwidth. Right here, you have to select it. We start at the lowest value, which is 111. And the width is, we decided it's 28. Compute. And here you go. This is the table. Relative frequency, relative frequency. Cumulative frequency means for the first one, it is the 7. For the second one, it's the frequencies of this class and that one. So 7 plus 8 is 15. And one thing I want you to understand from StatCrunch, the parentheses means the number is not included, and the bracket means the number is included. So actually, if you want to rewrite this, it will be 111 to 138. The next one will be 139 to what? 1 less, which is 166, and so on. So these are the actual classes. How do you create a histogram? Let me remind you again. Just go to graph, histogram, variable 1, and scroll down to bin. We start at 111. And what's the width, guys? 28. And that's it. Hit compute, and you're gonna see it. That's the histogram. It goes from 111 to 138, 138 to 139 to 167, and so on and so forth. And this is the histogram. You can also use an applet to do a histogram. Select the column, hit compute. This is your histogram, and now play a little bit with the slider. Let me show you. There's a slider, guys. So starting point is 111. I'll change it to 111. Oops, why it's not? Okay, that's 111. I don't know, it didn't pick it up, so the other way to do it is the best way. Let me see if you can do the 28 here. If not, just do the graph just like I suggested before. Yeah, it's not even showing me. Every time I do it, it just, yeah, that's it. That's how you do it, okay? All right, next. How do you find mean, median, and mode of a data set? So let me show you. Let me just erase this data right here. Okay, simply, guys, you go to stats, summary stats, columns, variable 1, compute. So here is the mean, here is the median, which is 160. You can get the mode as well. The mode is the value that repeats most often. Do you see any value here in the data set that repeats most often? We got 134, we got 145, we got 155, we got 160. Usually if you have more than 2 modes, we say there are no modes. So it doesn't seem like there is a mode. I mean, you can list the ones that repeat most often, the 134, 145, 155, and 160. Okay. So this is how you find the measures of center. Now, if I ask you to find the standard deviation, here's the standard deviation, guys. It's right here, 37.79. The variance is the square of the standard deviation. And the range, guys, is the difference between the lowest value and the highest value. Okay. Now, if I ask you to find the 5-number summary, the 5-number summary is the minimum, which is 111. It's a Q1, which is called the first quartile, which is the middle of the first half of the data set after you put them in order. Q2, which is the second quartile, which is the median. And Q3 is the third quartile, which is the middle of the second half of the data set, which is 90. So minimum, maximum, Q1, Q3, and median make what we call the 5-number summary. Now, how can you create a box plot using the 5-number summary? Let me show you. Select the column. And look, guys, here, draw boxes horizontally, and you're going to see a nice. This is the histogram. Okay, how do you interpret, and not the histogram, this is the box plot. If you don't see any dots standing alone outside of this box plot, that means probably we don't have any outliers. But if you see like a dot right here, this dot probably could be an outlier. How do you interpret this box plot? If this line, which is the median, this is, guys, the minimum, this is a Q1, this is a Q2, this is a Q3, and this is the maximum. Okay? If the median is right in the center and both tails, they call them whiskers, are of the same length, then the data is symmetric. We have a symmetric histogram. But if the longer tail is to the right, so if the right tail is longer here, and the median is going a little bit more toward the left, it's not in the middle, then the data is skewed right. So you can safely here say that the data is skewed right. Okay, so this is about the box plot. How do you create? Okay, what else we're gonna do here? So this is the box plot. This is make sure if you want to check if there are outliers, just under edit, make sure always to select this one. Use fences to identify outlier, and draw the box horizontally. Then you'll have it in horizontal mode. But let me show you what happens if you have outliers. So I'm gonna put this data set here. So look, okay, right here. All the values are like between 4 and 7, and all of a sudden we have 18. Let me show you if we do a box plot, what you're gonna notice. So you go to graph, box plot, variable 2, draw boxes horizontally, compute. Do you notice, guys, that this point is outside, just of the construction of the box plot? That means this number is an outlier, and if you hover over it, it will show you it's 18. So this is an outlier. This is how you can use StatCrunch to find outliers. Let's talk about the standard deviation a little bit. We did it already, but let me just do it again. This is the standard deviation. If the standard deviation is large, that means there is not much consistency in the data set. That means the values are widely spread out from the mean. If the standard deviation was very small, that means most of the values are very close to the mean. For example, let me give you this example right here. Okay, let me show you what the mean is, and watch what the standard deviation is going to be. So let's go summary statistics column, variable 3. I want the mean, and if you hold down the control key and press it, you get the standard deviation. You see those two. The mean is 5.6. Look at the values, guys. They are all very close to 5.6. So look at the standard deviation. It's very small. It's 0.59. So a smaller standard deviation means the data are more consistent. But if the standard deviation is large, that means data values are pretty much, widely spread away from the mean. They're all over the place. Okay, so this is how we interpret a standard deviation. The last thing I wanted to talk to you about is the z-score. The z-score will tell us how many standard deviations a value deviates from the mean, whether it is above the mean, by how many standard deviation, below the mean, how many standard deviations. The formula for the z-score, and this is very important, z equals value minus the mean, and then you divide by the standard deviation. So let me just show you this. Oops. And then divide by the standard deviation. If it lets me, I'm just trying to write the formula right here. ST. So how do you calculate, just the z-score? Let's take the original data set. Okay. For the original data set, what was the mean and the standard deviation? Let me just do it one more time. Variable 1, I want the mean. Hold down the control key and select standard deviation. This is all you need. So the mean is 166.72. and standard deviation is 37.27. So for example, guys, if I tell you take this value 200 right here and change it to a z-score, what would the z-score be? So you say z equals, you put 200 first, minus 166.72, and then divide by what? 37.28. This is how you compute the standard deviation. Okay. Now, not the standard deviation, the z-score. If the z-score is more than 2 or z-score is less than -2, your data value is unusual. If the z-score is between -2 and 2, guys, you say the data value is usual. So usually z-scores are always between -2 and 2. If they go beyond that, you call them unusual values. This is very much what you need to know in this chapter, and I hope this video will be helpful to you.